In this class, we're going to be looking at exponential equations. Exponential equations are also called index equations, okay? An index equation or an exponential equation is an equation where the variable is the exponent. The unknown or the variable is a power. Any equation that has the unknown as a power is called an exponential equation. Okay, so to solve exponential equation, we will have to apply the laws of indices. Okay, the trick there is to try to write the basis to be the same. Okay, when we write the basis to be the same, then we can equate the powers. So one of the tricks to solving exponential equations is to make sure that the bases are the same, and once the bases are the same, we are going to equate the powers. So let's take these examples. Example 1, solve 2 raised by x plus 1 is equal to 16. Okay, on the left hand side we have a base of 2. So what we're going to do is to try to write 16 to a base of 2. So you ask yourself, 2 raised to the power what number will give us 16? Remember that 2 raised to the power 2 is 4, 2 raised to the power 3 is 8, 2 raised to the power 4 is 16. So instead of writing 16, we're going to have 2 raised to the power x plus 1 on the left hand side. So for 16 now, we're going to write 2 raised to the power 4. Okay, so 2 raised to the power 4 is the same thing as 16, but we want to write it to base 2. Why? Because on the left hand side we have a base of 2 already. So since the bases are now the same, since the bases are the same, we equate the powers or the index or the indices, the powers. So the reason we're equating the powers is because the bases are the same. So on the left hand side the power is x plus 1, on the right hand side the power is 4. Okay, so you can see now that this is now a linear equation, in which case we're going to subtract 1 from both sides. So we have x plus 1, we subtract 1, and then we do the same thing on the right hand side, we subtract 1. Plus 1 minus 1 is 0, so we have x on the left hand side, and then we have 4 minus 1 on the right hand side, giving us 3. So our x is equal to 3. You can always confirm if your answer is correct. Okay, if we have 2 raised to the power x plus 1 is equal to 16, and then x is equal to 3, so I'm going to have 2 raised to the power 3. We're now putting s as 3, and then plus 1. 3 plus 1 is 4. I have 2 raised to the power 4. What is 2 raised to the power 4? 16. You can see 16 on the left hand side is equal to 16 on the right hand side. So that shows us that the answer. So you can always check if your answer is correct. Okay, let's take another example. This example we have solve 3 raised to the power 2x is equal to 81. 3 raised to the power 2x is equal to 81. Remember what I said in our first example. One of the ways to solve exponential equations is to ensure that we write the two sides of the equation to the same base. Since on the left hand side we have base 3, it will be very convenient for us to write 81 to a base of 3. So 3 raised to the power what number will give us 81? 3 raised to the power 2 is 9. 3 raised to the power 3 is 27. 3 raised to the power 4 is 81. So 81 is 3 raised to the power 4. Here we're going to have 3 raised to the power 2x on the left hand side. Instead of 81 now, we're going to write 3 raised to the power 4. Now you can see that the base on the left hand side is the same thing as the base on the right hand side. Since the bases are the same, Since the bases are equal, we equate the powers. We equate the powers. You can say we equate the indices. Okay, so on the left hand side, the power is 2x. On the right hand side, the power is 4. In this case, we're going to divide both sides by 2. So 2x divided by 2, because 2 is the coefficient of x. So I have 4 on the right hand side divided by 2. So if 2x is divided by 2, we have x. If 4 is divided by 2, we have 2. So our x is equal to 2. I hope you understand this. For us to solve exponential equations, we have to try to write both sides of the equation to the same base, and then if we're able to do this, we can now equate the powers. So let's take this question from WAEC. So this question is from WAEC. Let's see. Say solve the equation. Say simplify. 2 raised to the power x plus 2 times 2 raised to the power 3 is equal to 2 raised to the power 6. 2 raised to the power x plus 2 times 2 raised to the power 3 is equal to 2 raised to the power 6. Okay, so look at this equation. This is an exponential equation where we also have to apply the laws of indices. On the left hand side, we have multiplication law. Okay, so I have 2 raised to the power x plus 2 times 2 raised to the power 3. The bases are 2, so we can combine the two terms on the left hand side. So we have 2 raised to the power x plus 2, that's the first power. Remember, the product of powers law says if the bases are the same, we should add the powers. On the left, the first power is x plus 2, the other power is 3, so we add plus 3. And then we still have 2 raised to the power 6. Alright, here we have x plus 2 plus 3, which is going to give us 2 raised to the power x plus 5, which is the same thing as 2 raised to the power 6. Okay, now the bases are the same. Since the bases are equal, we equate the powers. We equate the powers. This is one of the simplest way to solve this kind of equations. Try to make sure that the two bases on each side of the equation are the same, or they are equal, and then we equate the powers. Okay, so on the left hand side, the power is x plus 5. On the right hand side, the power is 6. Okay, here we have x plus 5 is now a linear equation. It's no longer an exponential equation. So we subtract 5 from both sides. So x plus 5, we subtract 5. On the right hand side, we have 6, we subtract 5. 5 minus 5 is 0, so we have x is equal to 6 minus 5 will give us 1. So the answer to x is equal to 1. Okay, so we will solve one more example from WAEC past question. Let's solve one more example from WAEC past question before we wrap up this lesson. In this question, we have solve 5 raised to the power x minus 1 is equal to 1 over 25. 5 raised to the power x minus 1 is equal to 1 over 25. Alright, so let's look at this. We have 25. We can write 25 as a power of 5. So we can write 25 as 5 raised to the power 2. Remember that we have 5 raised to the power x minus 1 on the left hand side. So on the right hand side, we can write 25 as 5 raised to the power 2. So we have 1 all over 5 raised to the power 2. Okay, I hope you remember the negative index law, which states that if you have a negative power, then the negative will turn to the reciprocal, and then we'll have the positive index. Okay, so this works in both ways. If we have reciprocal of a positive index, we can write it as a negative power. So 1 1 over 5 raised to the power 2 can be written as 1 over 5 raised to the power 2 can be written as 5 raised to the power negative 2. Okay, because if this can be written as this, in the same way, this can also be written as this. So it's like a reversible process. Alright, so what this means is that 5 raised to the power x minus 1, we're going to now write 1 over 5 raised to the power 2 as a negative index, which is same as 5 raised to the power negative 2. Okay, we can see that both sides of the equation are now to the same base. Okay, since the bases are the same, we equate the powers. So on the left hand side, the power is x minus 1. On the right hand side, the power is negative 2. So we're now solving for x. This is now a linear equation. We're going to add 1 to both sides. Or some of you will say move minus 1 to the right hand side, but the correct expression is to add 1 to both sides. So x minus 1, we add 1, is equal to negative 2, we add 1. Minus 1 plus 1 is minus 2 plus 1 is equal to minus 1. So x is equal to minus 1.